Okay, so here we are. We've covered all the material, and we'll talk about the exam today. So first of all we're up to date now finally on all the videos. So all the videos are up for all the classes so far. I still owe you slides, which I'll try to get out today. And I have the midterm exam grades in my hands. I have to tabulate them. Hopefully by tomorrow, I'll have the midterm exam grades out. So you have to take an exam. I'm so sorry. I don't like writing it. I really don't like reading it. And you don't like taking it. But here we are. It's a thing that has to happen. So we're going to have an exam. Time and place are by the exams office. It's posted up there now. I have a history of relaying things wrong, so I'm not saying it myself. Look yourself, and you'll be in better shape. It's in the RDS somewhere. Miserable hall. In the usual exam schedule thing, right? Okay. The format. It's 2 hours. 2 hours. You have 3 essay questions to answer. So essay problem questions, right? So the Fisher-Gray is counting that as essay, meaning it's not multiple choice. You're going to have a book. You're going to be writing in the book for 2 hours. One of the questions will be a Fisher-Gray question, like the homeworks, like the practice problems. Will, for sure, be just like that. I mean, different problem, but it'll be the same thing. Solve it, interpret it. Why does it work this way? It'll look just the same. 50% of the exam, you know that's what it's going to be. Okay. Right. That was quick. Subjects we covered. Everything in the course is fair game. And we have 3 main subjects. You may notice 3 questions, 3 main subjects. I don't know, it could be a hint. Our first subject is the Phillips curve. Second subject is rational expectations equilibria using the Fisher-Gray model. Right? An example of a class of models. And the third is the ISLM model. Okay? We know for sure this one's going to be there. You can take your guesses about the other ones. Right? Okay. So in the Phillips curve, what did we learn in the Phillips curve? Broadly speaking, we talked about adaptive versus rational expectations in the Phillips curve model. I didn't put it down, but we talked about inflation bias. Right? That's part of the long-run equilibrium for either adaptive or rational expectations. So what's going on with the inflation bias? And the Lucas critique. Those are the things that we got out of that. Okay. In the Fisher-Gray model, we talked about the assumptions of the Fisher-Gray model. I will not ask these directly. You will be asked to interpret your results. Right? You'll be solving a problem like the homeworks, like the practice problems. You'll be asked to interpret the results, knowing what the assumptions are on about in a broad way. Now, you don't have to parrot them back to me or anything. But if you don't understand the assumptions, it's hard to interpret the results. So in that sense, it's there. But I won't directly ask about that. I won't ask you to manipulate them or anything. You will, for sure, need to solve a Fisher-Gray model using the guess and verify method. This is for sure, for certain. This will be there. Okay, count on it. Pencil it in your diary. On that day, you're going to be solving a rational expectations Fisher-Gray model using the guess and verify method. Just like in the homeworks, just like in the practice problem. Okay? Exactly the same thing. Different assumptions to the model slightly, but it's going to be the same process exactly like the homeworks and the thing. So clearly, you should get yourself to the point where you can solve those without reference to the answer keys so that when you're doing it on the day. And my thought and hope and intention is that if you get to the point where you can solve the practice problems and the homeworks without reference to any of the notes, you will do great on this question. Right? It is not intended to be a trick question. It is intended to be, did you study up? Did you learn? Because it's hard to learn, right? But did you learn this thing? So that you can get the answer without reference to the notes. If you can do that, I expect you to do really, really well on this section. Okay? We will see, and you will tell me. But that is my intention, hope, and expectation. That if you can solve those without reference to the notes, you will be good. Okay. You will have to, of course, interpret the results. And interpreting the results comes down to, can monetary policy affect output in this model? And why or why not? Right. you will have to explain the why, you will have to explain the why not. You don't have to go on for pages about it, but you should know. And in fact, going on for pages is often bad in the sense that it starts to feel like they don't know what the main point is, like a paragraph. If you know the main point in a paragraph, you can say it. If you don't, you can ramble on for pages and say all kinds of wrong things, right? So we're not expecting a long essay there, but we are expecting, do you know why it affects output or why it doesn't affect output in this particular version of the model that I give you? Okay. Yeah, that's this, right? Yeah, that's that. All right. And from this, we got time inconsistency. And we forgot. We got time inconsistency, and we got the Taylor rule. Right, both of those. Right. We talked about time inconsistency in direct relation to the model, and then we talked about the Taylor rule in relation to this class of models and why we use that. Yeah. So time inconsistency is one of the ways that policy can affect output in this model is through promises. That is, investors are forward-looking. And so if prices are going up, they want to invest now. So if I go to them and I say, I promise I'm going to increase money supply. Therefore, prices are going to go up. They're going to buy stuff now, and that will make output go up now. Okay? And that's great. I promised them this stuff, and then when it comes time to deliver, maybe I don't want to have inflation. And so I have this incentive not to follow through on my promises. Okay, that's time inconsistency. It can be optimal to promise it at the time, and it can be optimal to intend to carry it out at the time. But when it comes time to actually give the promise, like to fulfill the promise, it might not be optimal to do that anymore because you already got what you wanted out of it. Right? The promise was in hopes of getting them to invest now. But that's already happened, and so now my incentive to fulfill my promise is less. Right? We can all see this in our own lives as well. Right? We have this incentive. We know people have this incentive. You make a promise. It makes sense at the time, but then later on, not so much, right? Yeah, come help me move, and I'll take you out for pizza later. Well, he helped me move. Now I'm not all that thrilled about the pizza thing, but promises are promises. That's time inconsistency. The incentive to fulfill your promise after you've gotten what you want out of it is maybe not so much. Okay. Then we talked about the ISLM model. We have finding the IS curve and shifts in the IS curve. We've got finding the LM curve, shift in the LM curve, see? And evaluating the effects of monetary and fiscal policy using the ISLM model. And one of the things we got out of that is the crowding out of private investment. When government spending increases, output goes up, but at the expense of private investment. Okay. Other questions about the broad subjects while we're here? Okay. All right, let me talk a little bit. Okay, I see intense writing, so I'll let people finish writing before I click the little button. Okay. On the Fisher-Gray question, because that's 50% of the exam, clearly that's coming. You've been promised it will be there for sure, unless I get hit by a truck, and probably even then. I hope I don't get hit by a truck. But when grading starts, I really hope to be hit by a truck. I just make it stop. Okay. It will be. You will be asked to find rational expectations equilibrium, which is just what you've been doing in the homeworks and the practice problems. Okay. This question is 50%, but just like the homeworks and the practice problems, it will have multiple parts. And the multiple parts is just to break it down so that it is mechanically possible to grade the miserable thing and to guide you a little bit on how to structure your answer. Right? But it's really one question, solve and interpret the Fisher-Gray model, right? This particular Fisher-Gray model, and the parts are to help organize your answer and to help make it easier for us to read. Okay. 50% of the exam, for better or worse. Yeah. You're going to be using the guess and verify method. It will involve solving the model and interpreting the results. And there's a new practice problem up, practice problem 2. And in that one, because I know I've talked to a bunch of students, and students are really scared about the guesses. The guesses freak you guys out. Like, what the hell am I supposed to guess? Like people seem to kind of have people that have worked a bit seem to have an idea about what they're doing. But sometimes you can interpret it one way and get one guess, interpret it another way and get a different guess, and you don't know which to guess. Rule of thumb is put more in rather than less. But the other thing is that it is not so bad if you guess wrong. Nothing horrible happens. The sky doesn't fall. The math doesn't tell you right away. The math will tell you that you guessed wrong and that what the real guess should have been. So, even if you guess wrong, it's not the end of the world. It takes you 15 minutes of going through the thing to find out, okay, that was a mistake. Unfortunate, but you can do that, right? It's 50% of the exam. It's okay. So in this practice problem, I have particularly asked you, make this guess, which is wrong, so that you can see what wrong looks like and feels like when you guess wrong. Okay? Obviously, I will not, in the exam, force you to guess wrong. That's just weird. But I put this on the practice problem just so that people get over this really scared of guessing wrong. Ideally, you guess right. But if you guess wrong, it is not a big deal. It is not the end of the world. The important thing is that when you get to the point where the math is showing you that it's wrong, that you know that's what it's giving you. So there's this time practice of guessing wrong. Okay, strategies for the exam. In terms of, first of all, we got the three main subjects. We got the three questions. And I'm not like an exam-taking genius, but it seems like kind of a hint. I don't know what might be on the thing. There's probably going to be an ISLM question. There's probably going to be a Phillips curve question. And there is for sure going to be a Fisher-Gray question, right? And we didn't cover super lots in those other two things. So you could, if you wanted to, sit down today and write an essay about ISLM. Right? Make a guess at what the question would be. And if you just regurgitated that essay on the day, it might not be exactly the question, but it would be a good chunk of what's there, because explaining ISLM, if an ISLM question comes, that's going to be a thing, right? You're going to have to shift the curve one way or the other, most likely, right? So, and same with the Phillips curve. If you just sat down and wrote an essay and then wrote that on the day, it wouldn't be perfect because it wouldn't be quite answering the question, but it would be in the ballpark and it would get loads of points, right? So you have the tools to start thinking about what your essay is going to look like and structure. If you make a guess about what those questions are likely to be, I think you could be pretty close. I'm not going to tell you what they are, but I didn't try to be super creative. I just want to know, do you understand the model? Don't you understand the model? That's what I'm looking for. So what you have to do is you have to, ideally you answer the question as asked, and that's beautiful and gorgeous and lovely, and that's ideal. But even if you don't know the exact answer or you're flustered on the day, write what you do know, right? And you can write that now and sort of be ahead of the curve and sort of think about how you're structuring your exam, your answer, and how much time you want to spend on it, given that it's probably in the neighborhood of 25% of the exam, right? Because 50% is going to Fisher-Gray for sure. So we got two other questions, probably 25%-ish, maybe a little more, maybe a little less, but something in that neighborhood. How much time do you want to spend on it? What does an answer look like? These are all things that you can do now. Just, pick something from ISLM, write a little essay about it, right? And see how long that takes you. And right? If you do that twice, I can't imagine you'll get a bad grade on the exam. Okay? You may not get a perfect grade, but you'll definitely get a good, decent, solid grade if you go through and do that exercise twice. Make up your own question. Actually sit down, write out the essay. If you do that twice, I think you'll be great. We will see, and you will explain to me afterwards, that was terrible advice. But I honestly think you'll be great if you do that, right? Solid anyway. Okay, so in an exam, always, we're asking particular questions. But what we want to know is, what did you learn in the class, right? That's what we want to know. And so if you know nothing about the answer, hopefully you know more. You tell me what you know in the class. what you learned. Leaving it blank, blank is what you learned in the class, which is plausible. But I don't think you guys showed up. But generally speaking, people who showed up learned something. Like, at least Ivan's on about this sort of stuff, right? Is at the minimum what you learned. And so if you write what you learn, you will get partial credit for that, right? And so always, like, you don't know the answer to, I ask a Phillips curve question and you don't know the answer. Write what you do know about the Phillips curve. Right? I'm wondering, do you understand the Phillips curve model? Okay, if you don't know the answer to my question, clearly you don't know everything about the Phillips curve model. But if you know something, why do we draw it that way? What's the history of the thing? Whatever you know, tell me that, and you'll get partial credit for it. Right? If you leave it blank, what can I do? Right. So don't freak out if you don't know, right? Put down what you know, right? And you can put down what you know now and practice, and then you'll have a thing to say about that. Okay. Now, always with writing, there's who am I writing to, right? Because that tells you how much detail you have to put in. And the person you're supposed to be writing to is a person who is a good economics student. You know, they do well, they study, but they haven't taken this class. Right? So, because what I want to know is, what did you learn in this class? And I presume you're a good economics student and you're taking the class. What did you learn? If you can explain it to that person, then I know that you know it. Whereas if, for example, for ISLM, you draw IS and you draw LM and you shift it out, and that's perfectly correct, I still don't know whether you understand the model. Right? I don't know whether you memorized that shift or whether you understood the model. If you draw it, but you don't label your axes, is it Y, is it I, is it W, what the heck is it? Is it price? I don't know. Well, I know, but I don't know that you know. Right? So you have to explain this stuff like a person hadn't seen it before so that I know that you know. Right? Okay. So label your graphs. For God's sake, people, label your graphs. Most people do, but Now, in fairness, it's a 2-hour exam. You don't have all the time in the world, right? Label your graphs the first time you use them. And after that, I know you know what's there. You don't have to be so super careful the second time, right? If you're going to be draw it once and then shift it, you can be a little looser with your terminology, but make sure that I know that you know the first time you use the thing. Okay? Because that's what I'm looking for. Do they know? And if you don't label it, I don't know that you know. Okay. Explain each thing that you do. If you're shifting a curve, why? Why, for God's sake, why are you shifting that curve? Why are you shifting it the way it's doing? How is that related to the economy in any way? Right? Explain each thing that you do. And that's, again, because the implied reader does not know that you know, and the implied reader doesn't know it themselves, so you have to explain why. Right? Pretend like you're writing a very abbreviated textbook on this. Right? Writing to your old self 4 months ago. What was going to be in this miserable class? Explain it to them so that the poor former self knows this stuff. And right, that's what we're looking for. Right? Do you understand it? To be sure of that, you have to explain it. Okay? You don't have to go on and on and on, but you have to be clear that you understand it. Right? Why do you draw the curves that way? Why do they shift the way they do? A couple sentences on each one. Again, doesn't have to be like a book, but it has to be clear that you know what's going on with that graph. Okay. Answering the math questions, and people have trouble with this because largely it's new, right? It's a new thing for most of you to be telling stories through math, right? You had math class back in high school, and it was sort of separate, divorced from the rest of the world. But now we're telling stories through math, and that's different. I mean, fundamentally, it's the same, but it's a sort of you're engaging two parts of the brain at the same time and trying to make them consistent with each other. And so you're not used to, most people are not used to writing about that. Right? So how do you go about answering the math questions? Obviously, you need to know how to solve the math. Right? That's a thing. But very importantly, very, very importantly, you need to explain what you're doing. And you can see examples of that in the answer keys to the homeworks and the problem sets. The practice problems. Right? You should have that sort of level of detail as you're explaining. I'm plugging this one into that one because here's where I'm trying to get to. Okay, I have this thing, this describes the world, and I want to get to here. Here's how I'm going about doing it. Okay. Why are you plugging one equation into the other? Where are you going? What are you trying to achieve? And this is important because, again, the question I'm asking is, how much do they learn in the class? And if you're doing algebra, there's a million ways to go wrong. You make a sign error, you know, there's loads of ways to go wrong. And if you make an algebra error, genuinely, honestly, I could care less. It's not really a problem for me. I make algebra mistakes, you make algebra mistakes. It's on the day, it's an exam situation. You don't have infinite time to check your work or anything like that. It can happen, right? Hopefully you don't, because it's easier if you don't, but it can happen. It can happen to you, it can happen to me, it can happen to all of us. But if you make an algebra mistake and you haven't explained what you're doing, I don't know what the hell you did. I got no way to know that you were plugging equation 1 into equation 2 if the result is wrong. You know, oh, what did they do? I don't know. What were they trying to do? I don't know. And so that's just wrong. Whereas if you explain, I'm plugging equation 1 into equation 2, I say, okay, sign error. Okay, they just screwed up the sign. It's not a big deal, right? So it's obviously better to get the algebra right, but I'm really wondering, do you know what you're doing? Do you know where you're going? Do you know why you're doing it? That's the big thing. The algebra is a means to an end, but do you know what you're doing, why you're doing it, where you're going? That's the big question. Okay? And an algebra mistake makes it more difficult to grade, makes it more difficult for you to interpret your results. It's all bad, but it's not the end of the world. But if you get lost in the algebra and you don't tell me where you're going or why, I have no way to know whether you understand what you're doing or not, right? And so that can take a B answer and turn it to a D really quick by not explaining what you're doing, right? Obviously, a perfect answer is going to be in it. You're going to get the algebra right as well, but it can be a pretty good answer, even with like fundamental algebra mistakes early on. But it can't be if it's not clear what you're doing, that you know what you're doing and why. So you have to explain that. You don't have to go on and on, a couple sentences each step. What I'm doing, why I'm doing it, where I'm going. And by the way, if you practice it that way, it will be so much easier to study for this, to say, I'm not okay, Ivan did this, Ivan did that. No, why? Right? At each step, why is he doing it? What's going on there? It'll be so much easier to take the knowledge that you get from the homework and apply it to something new if you know why each step is happening, not just memorize a cookbook of 5 steps. And that's what I just said. Okay. And if you get totally lost in the algebra, right? It's going to be a math question. It's going to look like the homework. It's going to look like the practice problem. If you get totally befuddled in the thing and it's just a mess and you know it's a mess, you can say, this is a mess. I know it's a mess. Like what? I don't know. But here's what I do know about the model. Given the situation, given the assumptions, here's what I expect the answer to look like. I expect monetary policy to matter for this reason. I expect monetary policy not to matter for this reason. And if you explain that, obviously not a great answer, but a passing decent answer, right? It's, again, what did you learn in the class? So you can totally screw up the answer and still get a passing grade on the question. You just have to keep your wits about you, step back, put down what you actually do know about it. Okay? Assuming you know something about it, obviously, right? But if you do know something about it and you screw up the algebra, you can still get decent answers. The other thing to say is if you have an intuition and you get to the end and it doesn't match your intuition, right? You expect monetary policy to matter, but it turns out in your answer it doesn't matter. It is okay and actually better to say, look, my intuition is monetary policy should matter, but in my answer, it doesn't matter. That means, that tells me, 1, you have the intuition. It tells me, 2, that you know how to interpret the results. Right? Let's say you have a very strong intuition that monetary policy should matter in this. Right? You have reasons to believe monetary policy matters. And you get a whole thing, and there's no gamma in your answer. Right? There's the thing. And now suppose you just made an algebra mistake. You don't know on the day, right? And then you say, I have this strong intuition that monetary policy should matter, but I look at my answer, there's no gamma in the answer that's telling me that in the math, monetary policy doesn't matter. I don't know which is wrong, my intuition or the math. I'm guessing my math because that's a lot of places to go wrong, but I don't know. That is a very good answer. Okay? Obviously, it would be ideal if they matched up, but what does that show me? It shows me, one, you've got some intuition. You have some reasons to believe what you're looking for. Two, it shows me that you know how to interpret the answer when you get it, right? Whereas if you said, monetary policy matters in my answer, right? Because that's your strong intuition. And it doesn't, that would say that you don't know how to interpret the answer when you get it. And so that's like a screw up. Like, algebra mistake's an algebra mistake. It's unfortunate, but it's not a big deal. But if you don't know how to interpret the answer, that's a real problem, right? Whereas the other one is, well, what can you do? Like, I make them, you make them, everyone makes them from time to time. On any given day, it could happen to any of us. It's not a big deal. It makes it hard to grade, but it's not a big deal. Right? It's less hard to grade if you're explaining your steps and explaining what you're getting as you go along, but you know, we'll deal with it. It's not a big deal. It still shows, look, you know how to interpret the results. You know that it's not matching your intuition. Right? If your intuition is solid, that's actually a very good answer. If your intuition is wrong, that's unfortunate. Right? That's not as good, but at least it shows that you're interpreting, you know how to interpret the results. And so you're trying to match up story with math, right? Because we want always our story and our math to match. And if they're not matching, you should come out and say so. Right? And that's important. That's a useful skill. That tells me that you're thinking like an economist in the modern way. It's just, you know, something went wrong in your math, something went wrong in your story. Unfortunate, but you're still thinking right. Right? You're still in the world of a professional economist, just, you know, on the day you made a mistake, which is fine. Okay? Not ideal, obviously, you'll lose points, but it still can be a solid answer. Okay. I want to play with it. Okay, so that's what I got about the exam. Questions about the exam? Yeah.
How would you go about getting the intuition for guessing whether monetary policy matters or not?
So,
Like, let's just say the practice question was not right space.
uh-huh.
How would you guess whether monetary policy, like?
Yeah, so what is our intuition? Yeah, what is our intuition? So let me see if I can draw. Is this going to work? Sometimes things work. No? Ah, yes. And is it recording it? No, it is not. Okay, let me. Over here. I'm just being particularly concerned about, about making sure that we get this recorded because, you know, it's the exam review session, so people get there. Okay, so we've got a piece of paper. Okay. So we have two main ideas here. The one is that we've got these wage contract things, right? So we have short-term contracts. And these are yt minus y bar is something like theta pt minus pt given t minus 1. Okay. So this is saying that people are picking their input prices in time t minus 1, and then they're stuck with those in time t. Right? So they're making their best guess about what the prices are going to be today. They made this yesterday, and they're stuck with those wages today. We keep talking wages, but of course it can be jet fuel or anything else, any input into the production process. Okay. So they're making those, and then for that type of thing, if So if the central bank has the same information that people had when they were making their decision, when they were locking themselves into these contracts, then those people can perfectly anticipate what the central bank is going to do, right? Because they're basing it on the same information. So if I know that I'm looking at the shock in t minus 1, and the central bank is looking at the shock in t minus 1, I already know that, so I can perfectly predict the money supply, and so I'm not fooled. Right? Because in this model, here, output is being changed not by prices, but by people's mistakes in predicting prices. Okay? And so if I have all the information that the central bank has, I can predict money supply, and therefore I won't make mistakes because of money supply. And output is affected by mistakes, not by prices themselves. So the money supply will still affect output. Still affect prices. Right? If you double the money supply, prices are going to go up for sure. But it won't affect output because it won't affect the price prediction errors. On the other hand, has better or newer or even just different okay, you can't see that. So if they have better information or different information, then people might be surprised. Because the central bank is using different information than people have when they're setting their wages, they can't perfectly predict what the central bank is going to do. And therefore, they're going to make price prediction errors because they couldn't predict the money supply. And therefore, money supply can affect output. Okay? Money supply will always affect prices, always. But it won't necessarily affect price prediction errors, okay? Your ability to predict prices. But if the central bank has better or different information than ordinary people, or whoever it was that was setting these wage contracts or jet fuel contracts or whatever they were, if they have better information, newer information, different information, then we can't perfectly predict them. And so whatever they do is going to be a bit of a surprise. Right? So if, in this particular example, right, here, if the money supply depended on ET minus 1, then we will be having exactly the same information that people had. Right? We have only T minus 1 information going into today's money supply, and therefore people already knew that T minus 1 information. They would be able to perfectly predict output. On the other hand, here, if we had equals gamma ET, people didn't know ET at the time they were setting their prices. Right? So they didn't know what this shock was, but the central bank does. So here's an example where the central bank can react very quickly to news, much more quickly than people can change their contracts. Right? People are stuck in these wage contracts for a while. Central bank finds out new information. They can change the money supply accordingly. And so people didn't know that information at the time they were setting their wage contracts. Therefore, the money supply will be a surprise because it's based on something that people didn't know when they were setting their wage contracts. And therefore, we might make price prediction errors because we can't perfectly predict the money supply because we don't know the things that it's based on. Okay. All right, so that's one set. That's our first idea. I'll call this idea 1. Our other one, idea 2, is we have forward-looking investors. Or indeed consumers. That is, people spend so here, I'm saying I'm going to be spending. So this is people that are deciding how much to spend now. And of course, spending now will result in output now, right? And so if I'm deciding to spend now, and I'm thinking, I'm going to spend if prices go up. I'm going to invest if the price of my product is going up. It's cheap to buy a factory now. My product's going to be worth loads tomorrow. So I'm going to spend now, buy a factory, so I can sell the stuff. Right? So this would look like, I can zoom out. Is that a possible? Yeah. This is going to be yt minus y bar is equal to theta pt plus 1 given t minus pt. Okay. Now it looks, and we can get those in the same, it's very similar, like if you weren't taking the class, and certainly like Gavin got onto me from the drop-in center. He's like, okay, he never took this class. I didn't teach this. I taught him way back in the day, but I didn't teach him this stuff, right? So he goes, what? These are the same. But no, it's subtly different. And it's important to notice that it's different, right? It's an expectation and it's a price prediction error, sure. But this one, we have spending depends on what I think is going to happen tomorrow, right? I'm not locking myself into a contract. I'm just thinking, if I expect prices to go up, I'm going to buy stuff now. And then if I promise, like it wouldn't even necessarily have to be based on anything. If I just say, I'm going to increase the money supply, then people will think, well, the prices are going to go up. And so if I increase the money supply, if I promise to increase the money supply tomorrow in t plus 1, prices will go up, and therefore people want to spend now because they expect the prices to go up. And so here, it is this promise of doing this thing that causes output to go up. So even if I don't have any better information, we all have exactly the same information, right? These guys are making their expectations in time t. They've got all the information there is, right? And whatever we base it on, fine. It's whether they expect me to increase the money supply tomorrow or not. If they do, then prices are going to be high, and so the output will be high now. Okay? But this leads, so we see the time inconsistencies, like even the very simple model, like we had in the homework. I think the homework. Even in that very simple model, the simplest one I could write that was this way, we got a situation where, yes, money supply affected output, but also last year's shock affected output, and they affected output in different ways. Because one of them is, I'm getting higher output because I'm promising to increase the money supply. But the other one is, now from my promises before, I've got to increase the money supply. And so you get your output change because you're making promises. But then keeping the promises can destabilize output, right? And so there's this trade-off between making the promise to get output high today versus keeping last period's promise so that I'm believable in the future. Okay? And we didn't talk about reputation and believability in the future in any kind of systematic model sort of way, but this is a huge issue in macroeconomics, right? Because lots of times, particularly in a crisis, you want to promise things to get people to get off their butt now. Right? Things are going to be great tomorrow. Come out, spend today, and that'll make things great tomorrow. But I'm going to do all this wonderful stuff. But then when it comes time to do all the wonderful stuff, maybe it's not so wonderful anymore. Right? It was good just because it got people to do stuff then, but now it's not so good. But then you have to say, well, do I keep my promise? Don't I keep my promise? In the model, we assumed that the central bank always kept its promise, right? That's how we solve the model. That's how we do all of this rational expectation stuff. But in reality, of course, it's not quite as clear. Okay? So this is the intuition. So we have sort of these two main reasons why money might affect output, or any policy, in fact, might affect output. This one, of course, has two subparts, whether we have better information or not. And this one is just promises, and that, given that people are basing their spending today on their expectations of future prices, we can always affect output. But only, it has a destabilizing effect as well. Did that answer your question? Yeah. Yeah.
When the central bank makes a promise of future monetary supply, would that be MT equals gamma ET equals 1?
So here's what I meant by that. Suppose we have MT equals gamma ET minus 1. Okay. It doesn't really matter what I put down for this. Right? It really comes down to this determines everything. But suppose I'm doing that. So I'm reacting to yesterday's shock. Okay? Very plausible. People have much better information than the central bank. Right? The central bank's only reacting to yesterday's shock. Right? And so people know today's shock. Well, they got great information. So on this first category, if we were thinking in this way, they'd have no effect on output because they got better information. But here, we aren't locking ourselves into contracts. We're thinking about this spending. And so what people know, okay, fine, today's money supply is based on yesterday's shock. But what that means is that tomorrow's money supply will be equal to gamma ET. Just one period forward on the money supply, one period forward on the shock. Which means tomorrow's money supply is going to be based on today's shock. And so when they're thinking about tomorrow, they're thinking, what is the money supply going to be tomorrow? Well, they know, for example, if the shock is high, they know that the money supply tomorrow is going to be high. And so they know the prices are going to be going up. Okay? So that's what I mean by a promise. In the sense that this rule, because we're making it a rule and we're forcing them to be consistent with it, is a thing we're doing now, but it's also, this is how we're going to be behaving in the future. Right? And so when we solve this out, we'll have, an effect of today's shock, but we'll also have an effect of yesterday's shock. And yesterday's shock term is going to be what's happening because we're keeping our promises from before. And today's shock term is going to be what we're getting because we're promising to do something tomorrow. Right? Because money supply, based on ET, money supply hasn't changed yet. But it will affect people's behavior because they know that tomorrow we're going to be doing something. Other questions today? Okay, so what I want from you guys is to take a look at the stuff. I know you got a million classes to do, but on Friday, I'm going to stand in front of you and I'm going to have nothing to say at all. I'm just going to be standing here and I'm going to be answering questions. So it is your chance to get all your questions answered. And so it is a good time to come up with a few questions to ask for next time. Right? Okay. Have a good week. Good luck in the final days.